Hey guys, let's cut to the chase. By 2025, China wasn't just leading the global shipbuilding game. They were dominating it so hard. The rest of the world couldn't even keep up. We're not talking a small lead here. China launched more ships that year than every other country on the planet combined. And not just a little more than double. But here's the kicker, right now, nearly 70% of every new ship being ordered anywhere in the world is being built in Chinese shipyards. Let that sink in for a second. That means the majority of the ships that will carry the world's oil, gas, and cargo for the next 30 years? They've already been designed, ordered, and are being built right now in places like Shanghai, Dalian, and Guangzhou. We're talking about oil tankers, so massive 3 football fields could fit end to end along their length. So tall, their engines alone stand as high as a 4-story building. So powerful, a single voyage carries enough oil to meet 10% of America's daily consumption. Enough to power entire countries for days on end. And let's be real, the US is watching this like a hawk. But the real question isn't whether China is winning the shipbuilding race, that's obvious. The question is, how did they get so far ahead that the race is basically already over? And more importantly, what does that mean for the rest of us? Because this isn't just about ships. This is about who controls the flow of energy on this planet. If that sounds like something you need to understand, hit that like button and subscribe right now. This is exactly the kind of deep dive we do on this channel. By the end of this video, you'll never look at the ocean the same way again. Let's rewind a bit. For decades, shipbuilding was a 3-way fight between Japan, South Korea, and China. Like a 3-legged race where each had their own superpower. Japan had the craftsmanship, passed down through generations. The kind of precision that makes every weld and cut feel like art. South Korea had the cutting-edge tech and a reputation for building ships faster than anyone else. They were the speed demons of the industry. China? They had scale, a massive workforce, and a hunger to grow faster than anyone expected. The rest of the world, especially Western nations, watched this and thought, hey, as long as they're competing, no one gets too much control. It felt balanced, stable, safe, and for a while, it was. But nobody saw what was coming next. China didn't just get better at building ships, they tore up the rulebook and rebuilt the entire system from the ground up. They didn't play the same game better than everyone else. They changed the rules entirely. And once you change the rules, the old scoreboard doesn't matter anymore. By 2025, China was cranking out 53.69 million deadweight tons of ships in a single year. That's over 56% of everything built on the planet. South Korea, which was neck and neck with China just a decade earlier, was left in the dust. Japan? Even further behind. That 3-legged race quietly turned into a solo sprint and China was the only one running. But the order books tell an even bigger story. Nearly 7 out of every 10 new ships being ordered worldwide are going to Chinese yards. That's not just market share, that's a preview of the future. The global fleet of 2040, 2050 ships that will still be sailing when today's teenagers are middle-aged are being shaped in China right now. And here's the thing, when you control what gets built today, you control how the world moves tomorrow. But to really get why that's a big deal, you first need to understand what these ships actually are. Because they're not what you picture when someone says ship. Let's talk about VLCCs, very large crude carriers. These are some of the biggest moving objects humans have ever built. A typical VLCC stretches about 330 meters long. That's longer than 3 football fields lined up. It's 60 meters wide enough to lay a multi-story building horizontally across the deck and still have room to spare. And it carries around 2 million barrels of crude oil in a single trip. To put that in perspective, the US uses about 20 million barrels of oil every day. One VLCC carries 10% of that one trip. The steel alone in one VLCC weighs 55,000 tons. That's roughly the same as 7 Eiffel Towers stacked on top of each other. And every single plate of that steel, every cut, every weld, has to be nearly perfect. The ocean doesn't forgive shortcuts. Think about the conditions these ships face. North Atlantic waves that can bend steel beams. Pacific storms that have swallowed ships whole. And 2 million barrels of oil sloshing around inside, slamming against the hull with every wave. That internal pressure shifts constantly, beating on the structure from the inside out. And these ships have to survive that for 25 to 30 years. Yet somehow, China can build one from raw steel plates to sea-ready in under 2 years. When you first hear that, it sounds impossible, but once you see how they do it, it starts to feel inevitable. Let's break it down. The ocean has one non-negotiable rule. If your structure fails, you sink. That's the foundation of China's shipbuilding philosophies. First, everything else second. A VLCC's hull has 2 layers of steel, separated by several meters of space. That gap is a buffer zone. If the outer shell gets pierced, the inner layer holds. It's a passive defense system. But in the open ocean, that can be the difference between a near miss and a catastrophe. Inside the hull, bulkheads' thick walls divide the space into compartments, not just for storage, but to control the sloshing of the oil. If the cargo surges too much, it creates dangerous shifting forces that could tip the ship. Those bulkheads manage the physics of that liquid, keeping the ship stable. Then there's corrosion. Seawater is brutal on metal. Salt, moisture, and chemicals eat away at steel, slowly, invisibly. To fight that, the interior tanks are coated with multiple layers of specialized epoxy chemical shield that keeps the steel safe. Every feature of these ships is built around survival. Only once that's guaranteed, do they refine the rest. And that philosophy carries over to how they build the ships, which is where things get really fascinating. Let's start with steel cutting, the make-or-break first step. Every one of those 55,000 tons of steel plates goes into massive computer-controlled cutting systems. Every cut is pre-programmed, with precision that doesn't allow for even a quarter inch of deviation. Why? Because a small error here doesn't stay small. A quarter inch off on one plate becomes a centimeter off on an assembly, which becomes a structural weakness in the finished hull. By the time you find it, you're not fixing a cut, you're rebuilding a section. So the standard has to be absolute from the start. But here's the innovation. Instead of building a ship from the bottom up, one layer at a time, a process that used to take 4 to 5 years, Chinese engineers sliced the blueprint into over 100 giant sections, each weighing 300 to 600 tons. They build each section completely separately on the ground, adding pipes, wiring, and coatings before it's ever attached to the main hull. Then massive cranes pick up these finished sections and lock them into place like the world's biggest jigsaw puzzle. This is called modular block construction. It's the same method aerospace engineers use to build rockets. The idea is simple. Do dozens of things at once, instead of one after another. The result? A ship that used to take 4 to 5 years now takes under 2, and the quality is better. Because each section is inspected and perfected before it becomes part of the whole. But how do you line up 100 giant steel blocks, each hundreds of tons, to within a hair's width? That's where China's tech investment gets mind-blowing. Across their biggest shipyards, millions of tiny sensors are embedded everywhere, feeding real-time data into AI systems. These systems monitor every measurement, every position, every tiny movement. If a section shifts even slightly, we're talking the size of a human hair, the system flags it immediately. No waiting for a worker to notice. This prevents small errors from piling up. A few millimeters off on section 5 becomes a few centimeters on section 50, and a catastrophic flaw on section 100. That invisible network ensures those blocks fit together like they were always one piece. Then there's welding. Every joint on a VLCC has to hold for 30 years in salt water, through storms, shifting cargo, and extreme temperatures. Human welders, no matter how talented, get tired. Speed shifts, pressure changes, temperature drifts. over thousands of hours. Even the best produce inconsistencies. So, China handed the most critical welding to robots. Laser welding arms work 24/7 on steel plates up to 50 millimeters thick, maintaining the same temperature, speed, and pressure with zero variation. The joints they make aren't just strong, they're consistently strong. Humans still handle the tight curves and complex geometries where adaptability matters. But automating the rest removed one of the oldest sources of failure in shipbuilding. Modular construction, AI monitoring, and robotic welding. This isn't just faster shipbuilding. It's a completely different way of thinking. And it produces a hull strong enough to carry 2 million barrels of oil across the world's roughest oceans for 30 years. But a hull is only half the story. The engine that moves it is just as remarkable. Moving a 300,000-ton ship across an ocean isn't just about a powerful engine. It's about engineering at a scale most people can't wrap their heads around. The engines are two-stroke diesel behemoths, built to generate massive force at low speeds. They don't spin fast, they spin slowly, and push harder than you can imagine. These engines are as tall as a 4-story building. Their cylinders are wide enough for an engineer to walk into for maintenance. They put out nearly 100,000 horsepower. But the real power is torque-steady, relentless force that drives the propeller. That propeller weighs over 100 tons, cast from a single piece of specialized alloy to avoid weak joints. Its blades are designed using the same fluid dynamics simulations as aircraft wings, to convert rotational force into forward thrust as efficiently as possible. Here's a mind-blowing stat. Improving the propeller's efficiency by just 1% saves up to $15 million in fuel costs per ship per year. Across a fleet of hundreds, over 30 years, that's economics that reshapes entire businesses. But there's one more challenge: vibration. A massive engine running at full power, combined with 2 million barrels of oil sloshing, makes the whole ship vibrate. The problem comes when the engine's vibration frequency matches the cargo's shifting frequency resonance. Like a singer shattering a wine glass. On a ship, resonance cracks, welds, fatigues steel, and shortens the ship's life. To fix this, the engine isn't bolted directly to the hull, it sits on a damping system. Sophisticated shock absorbers that absorb vibrations before they damage the structure. The result? A ship that runs smoothly, even in rough seas, for its entire 30-year life. Now, take all that engineering and apply it to a new generation of ships. Because China's newest tankers aren't just better than before. They're a whole new philosophy. Take the Xinadin, a 300,000-ton VLCC with 40-meter-tall rigid sails made of ultralight carbon fiber. These aren't decorative, they're aerodynamically engineered to capture wind energy, cutting fuel consumption by 9.8%. That sounds modest. But on a ship that burns tons of fuel daily, it saves millions per year, per ship. Over 30 years, that's a fortune. Then there's the Yuan Ruiyang, with a dual-fuel system that switches between diesel and liquefied natural gas, LNG, depending on costs, regulations, and environmental standards. It cuts CO2 emissions by 20% and sulfur emissions by up to 85%, meeting the strictest global shipping standards. Standards most older ships can't touch. And these new Chinese tankers are built to last 30 years instead of 25. 5 extra years sounds small. But for a ship carrying millions of barrels per voyage, that's hundreds of millions in extra value. When a ship is more efficient, cleaner, smarter, and longer lasting than the competition, at the same price. With flexible financing from Chinese state-owned banks that removes upfront costs. The decision to order from China isn't a preference. It's inevitable. But here's what most coverage misses. The real power isn't in the steel or the sails. It's in what these ships represent for the global energy system. 60% of all oil traded worldwide travels by sea, not pipelines, not trucks, not trains. And the vast majority of those ships were built in China. That creates a direct link between Chinese industry and the global flow of energy. Every barrel from the Gulf to Europe, the Middle East to Asia, West Africa to the US, overwhelmingly on a Chinese-built ship. And it doesn't end when the ship is sold. Building the ship creates a 30-year relationship. The shipping company needs spare parts designed for that specific ship. Technical support from engineers who built it, maintenance, software updates, all of that comes back to China, year after year. Chinese state-owned banks made this even stronger by changing the financial game. Historically, the biggest barrier to ordering a ship was the upfront cost. A VLCC costs hundreds of millions. Chinese banks offered financing that spreads the cost over time, with low rates and flexible terms. Suddenly, shipping companies from Greece, Norway, the Middle East, and Asia could order more ships, more often. Every order deepens their connection to China's shipbuilding ecosystem. Organizations like BIMCO, the world's largest shipping association, have raised red flags. When most of the world's shipbuilding capacity is in one country, a disruption, trade tensions, natural disasters, supply chain shocks sends shockwaves through global shipping that take years to fix. The dependency is structural, not just economic. But there's a longer-term shift here that's even more important. For most of modern history, power in the global energy system was with the countries that had oil in the ground: Saudi Arabia, Russia, the UAE, the US. The ones who could turn a valve and change prices. But oil in the ground doesn't go anywhere without ships. And ships don't exist without shipyards. So if you control the means of transport, you hold influence without owning a single oil well. China isn't setting OPEC quotas or drilling in the Gulf. But they're building the ships that carry 60% of the world's oil. And the ships being built now will sail until 2055. The infrastructure being created today will define how energy moves for the next 30 years. Long after today's energy policies are forgotten. This isn't a shipbuilding story anymore. It's a story about who holds the quiet levers of the global economy. Not with military force or political pressure, but with steel, robots, carbon fiber sales, and financing terms that make it easier to say yes than no. When you build enough ships for enough of the world, over enough decades, the ocean stops being a natural boundary. It becomes a network built, maintained, and controlled by someone. That someone is China. China didn't just build the world's largest oil tankers. They built the system that builds them, finances them, and keeps them running for 30 years. And in doing so, they quietly positioned themselves at the center of how energy moves across the planet for decades to come. So, here's the question I want to leave you with. When the infrastructure that carries 60% of the world's oil is built, maintained, and financed by one country, does that country hold a kind of power over global energy that nobody voted for? And nobody can easily undo? Drop your thoughts in the comments below. I read every single one. And I genuinely want to know where you stand. If you found this video worth your time, hit like and subscribe. It helps more than you know. And check out the next video if you want to keep pulling on this thread. Thanks for watching, and I'll see you next time.